Hey, I'm Pat, and in this video I will be going over exploits and how you can prevent them, how they work, pretty much all of that. Before you watch this video, you need to at least have an understanding of remote events and the server and client. So the first thing I want to talk about is how exactly an exploit really works. So a player can see anything on the client. So what is the client? The client is all the local scripts, any module scripts that the local scripts require, pretty much anything inside relocated storage. This is actually my strength simulator game. It's in my beginner projects video, but if you look and we play the game, this is what an explorer can see. They can see pretty much all this stuff. They can see everything inside a workspace. They can see players, they can see starter pack, they can see replicated storage, they can see what remotes we have. And if we go into test and we switch to the server, now what we can see is pretty much everything that we can see if we were inside Roblox Studio editing. So we can see now, we can see all the server scripts and everything under server script storage, whereas if we're on the client, we can't see anything inside of those. We can't see anything as far as server scripts. But we do have access to the workspace, and per se, if we want to move this part, we can move it for us. But if we go back to the server, you'll see the part is still under us, but on our side it's over here now because we moved it on our own client. Now, something important to take note is that a player's character is actually owned by the player's client. So if we were to move our own character, like over here, even though we just did this on the client, it actually replicates to the server because our client has network ownership over our player. So that means anything that an exploiter does to their character will replicate it, meaning that they can play animations on their own character, they can teleport their character, they can fly, they can no-clip through walls, they can change their walk speed, their jump height, literally everything. They can do whatever they want with their character's movement or behavior, whatever they want. And you could have server checks to stop this, so you could have maybe like a heart step event or function that checks how fast your player is moving, not by checking their property, but maybe comparing their last position with their current position and getting magnitude to see how far they moved. If they moved too far between each position, maybe they teleported, or they're using speed hacks, or maybe they're flying or something like that, right? So that's one way you could figure out if a player is doing something suspicious in those sense. And the way an executor works for scripting or exploiting is they can pretty much run a local script. They have access to all your local scripts. They can see your local scripts, they can read them, they can change them and replace them, they can do whatever they want with your local scripts. And that is because when a player plays a game, everything is given to them. So like the map, in order for the player to need to, or if I stop having aneurysms, in order for the player to be able to see the map, they need to have the map on their device, so that way they can display it, right? Their computer needs to know what the map looks like in order for the player to be able to see the map. And it's the same idea with websites, where when you visit a website, you actually can inspect element and edit the website any way you want, if you notice that, right? You have access to the website completely. Well, not completely, you don't have the access to the backend, but it's the same idea with Roblox, where you have access to pretty much everything. And it's like that with all games. Any game, you can just go into the game and you can steal the game's entire map. There's nothing the other person can really do about it, because in order for you to be able to see the map, they have to give you the map's information. And the same thing for local scripts. In order for a local script to run on a client, the local script has to be given to the client to run. So you will have access to any local script from any game pretty much. If you're exploiting, or even if you're just playing the game normally, you still have access to it technically, but you can't really get to it unless you have a tool developed for that. What else was I talking about? So everything replicates that's done to the character. They have the ability to see your entire map, steal your map, do whatever they want with your map. all your local scripts, they have access to all that. They can fire any remote event they want, so that's something that you need to keep in mind, is when a remote event is being received on the server, like on server event or on invoke or whatever, on server invoke, you need to make sure that what the player is giving the server is valid. You need to make sure that the player has enough coins to maybe purchase something, or they're within distance to buy something. Like, make sure that they're actually close enough to something to buy, or open the GUI, or make sure that they actually have permission to be in the area that they're in. Like in simulators, there will be like different zones. Make sure that the player actually has the zone unlocked if they're like inside that zone. If they don't, maybe they should be reset or something like that. These are all things that you should be verifying through server scripts, and you can do it on local scripts, but theoretically the player could just take that local script and delete it, and there's nothing you can really do about it. So you had to use mostly server scripts to verify things, and one that is pretty much called sanity checking, where you have an if statement on the server script side of a remote event to verify that what the player is doing is something they were supposed to be doing at that moment. For instance, if a player is trying to buy something from a shop, on the server side, you should make sure that the player is close enough to that shop to even be able to buy anything in the first place. And you should also make sure that the player has enough money to buy the item that they're trying to buy. So, next what I'm going to do is I'm going to show you a little video of me reviewing an exploiter attacking this very game. My editor will hopefully put that in now, or whenever he feels like it, but we're going to go ahead and look at that real quick, and I'll come back and we'll review the scripts and show you how we can improve the scripts to prevent an attack like that happening. Alright, so here I have a example of somebody attacking my strength simulator game with Synapse or whatever, right? So obviously this is clearly not me, alright guys, so this isn't me, this is some random person doing it. You know, they just recorded it and decided to accidentally send me it. But so the idea is we're gonna look over it and see how a clearly experienced exploiter would go over trying to you know, attack remote events or remote functions, and kind of get a deeper dive into how exactly exploits work, what an exploiter can and can't see, all that. So here's the video. You can see they have a little script hub here with darkdex, remote spy, and a script dumper. They open up the console so that they can see the output, and then they try and buy a dumbbell. And the thing that they're doing here is they actually enabled remote spy. If you notice, they executed it, which means that it's now working. You can see in this little window that they're using the output, the developer console, as a way of displaying info about remotes. And you can see the idea is with remote spy is whenever a remote event is called, it will tell you what arguments were passed with the remote event call, and it'll also give you the name of the remote event and what script fired it, things like that. You can even see a little preview of it here. So what they're doing is they're trying to see what remote event fires when they try and buy a dumbbell, and you can see it doesn't work because in my game, I'll show you later, but on the local script it has a check to see if the player has enough money on the local script, and if they don't have enough money, then it returns and skips over the remote call. So it doesn't actually call a remote if they don't have enough money, and obviously in this case they just joined the game, so they have no money. But next thing they're going to do is they're going to try and use darkdex here. So you see they execute it, and this is what dex looks like. You can see it's pretty much just like the Explorer in your game. They can see, you know, all the services, everything. You'll notice though, they can't see server script storage or server storage, but they can see pretty much everything else. And you'll see that it even shows them all, like the different services and everything. But you see they go straight to replicated storage here, and they go into a remotes folder, and you see the purchased bindable remote. So what they're going to do is they're going to try and figure out how they can use this remote to give themselves the tool without having enough money, right? So next thing they're going to do is they're going to work on trying to find the script that calls the remote. So they're going to go to the GUI. In this case, we only have one GUI. Kind of easy for them to find it. They just go to shop GUI, and then you go to shop handler, and they're going to go ahead and use the script viewer to see it. Script viewer for dark decks, I believe their decompiler is pretty bad. This is what decompiled code looks like, by the way. So just something to keep note is when code isn't compiled, all the variable names are taken away, since the computer doesn't actually need to know variable names. So all the variable names in decompiled code are always going to be like v24 or u7, something like that, instead of like the normal variable names that we use in our code. So it's a little bit more confusing, and obviously this code is much more different from the actual script I have. If you want to see the actual script, you can download this entire game from my 3 scripter projects video or whatever. But he's going to go ahead and look through this code, and he's going to try and figure out where this remote event is called. Here you can see right here he finds it's called there, and eventually he gets to the point where he realizes, hey, this isn't working, this is pretty trash. So he goes into Visual Studio and pastes the code into there, and now what he's doing is, you can see when we invoke the server, it has 2 arguments, v18.name and p1. So he wants to figure out what p1 is, so that's what he's working on right now. You can see when he highlights p1, it highlights all the p1. So you can see that p1 is a parameter in the function call, so he's going to go and look to see where the function is called. He finds it down here, and he sees v24.storeType. So he can see that the p1 variable is the store type. And what he's actually going to do is even have a little comment for a note to tell him that p1 is the store type. And with that figured out, he pretty much has an idea as for what information he needs to give the server. He knows that he needs to give the server the tool's name, and he also knows that he needs to give the server the store type. So now what he's going to do is go back into the game and get his executor, and what he's going to do is check the path for the remote. So he scrolls down so you can see the remote where it is, and then he just goes ahead and gives it a try. He's not going to get it first try, but he will figure it out eventually. So he goes over to the store to see what the name of the tool is. So he goes and he's going to do big dumbbell, and then he tries to you can see he goes into the workspace and he tries to use a store name, the dumbbell store, and you'll notice that doesn't work because that's not how the script works. But another problem is he also didn't put the argument inside the actual invoke server call, but whatever. So you see, once he executes it, this is what remote spy looks like. It says remote function called, from script, tells you the script, tells you the path for the remote, and tells you the arguments that were passed, big dumbbell right here, and it says it didn't return anything. So if we go ahead and keep going here, you'll notice he realizes that the name was probably wrong. So he goes into replicated storage and looks at the tools to realize that the store type kind of tells you which folder the tool is under. So after that, he goes ahead and he's going to try dumbbells. He realizes that he didn't have the argument in the right spot, so he moves it back in to the right spot. Then he tries it, and you can see as soon as he executes it, it gives him the dumbbell, and he can instantly start giving himself some free strength. You can see it still took money away, but he obviously didn't have enough money to buy the dumbbell, but he got it for free through exploiting pretty much. So that's really the idea behind how an exploit works. And now we're going to get some more information here. So this is the map downloader tab here, and you can see it gives you the options to save workspace. So pretty much all the children of workspace, which will give you the game's map, lighting, replicated storage, replicated first, starter pack, starter GUI, starter player. Allows you to save pretty much everything, right? And you can see down here at the bottom it says save. You click that button, and just saves everything to a file that you can open in Studio. And the script viewer obviously can steal those decompiled scripts as well. And it gives you some more settings here as well, whatever. Yeah, that's pretty much it. You can see, go back to the script hub again. You can see that there's a script dumper, and this will pretty much just take all the local scripts and module scripts that the client has access to and decompile them and store them inside of a file that you can open up in Studio, and that way you can look at all the game's decompiled scripts in a much easier way, since that will actually use Synapse's decompiler, which will be much more cleaner and easier to read than whatever Dex has. I don't know what that was, but that was pretty bad. But that's pretty much how what exploiting really looks like. Obviously nothing too crazy. They got some more options down here, like they can open up a .lua file, they can clear it, execute the file, save their script to a file, attach will pretty much attach the executor to the game, or inject, whatever. And then they got some files here that they already used, obviously. So that's pretty much how that works. I'm going to go back to the main video now, but hopefully that gives you a good understanding of what exploiting looks like. Alright, so what I'm going to do now is I'm going to show you how we can prevent an attack like that happening. What we're going to do is we're going to go into our shop server handler. So this is the server script that handles our purchase. So on server invoke, it will call this function. So we get the player, the item, and the category of that item. And what we do is we find the tool under the category, we get the currency, and then we just straight up subtract the player's currency for the price, and then we give them the tool. We don't check to see if they have enough money for that tool. We don't see if they're within distance. If you noticed in the video, the player wasn't even standing on this green thing, but he was still able to buy the dumbbell. And if you notice down here in the shop handler, if you go into here, we have this check here to make sure that the player has enough money, right? So it should be safe, right? When the player clicks it, we check to make sure they have enough money, so it should be safe. But no, that's not really the case, because obviously the explorer can still fire the remote event anyways. There's nothing we can really do to stop that other than to check to make sure that they're allowed to purchase that item on the server. So what I got here is some sanity checks. This first one is mostly just to make sure that the player doesn't already have it. So this prevents the player from giving themselves multiple tools of that type, which is pretty important, because you don't want to give like the player multiple tools of a singular type, because maybe they could give it out to people, or they could potentially duplicate them, and you know, they could they could duplicate them. They could have multiple tools around their player and like farm faster with like multiple tools. They could do whatever they want, but I mean, ideally for some games you might want to have it so they can have multiple tools, but in this case we're making sure that they don't have more than one of that tool. Now what we're doing after that is making sure that we found this tool in the storage. I didn't really need to comment that out, but this next line is very important. This is us checking to make sure that the player's currency is greater than the price. So if the price is more than how much currency the player has, then we'll just return false and end. Alright, and the next thing that we could theoretically do is have a sanity check to make sure that they're within distance with one of the stores at least. We can do this by looping through the stores and checking the player's humanoid report's magnitude with each store, and if they aren't within distance of one of them at least, then we can return false, or we can check to make sure that the player is within distance of the store that they're trying to use. In this case, my game isn't really made for me to make that sanity check too easily, so I'm not really going to do that in this video, but it's an example for something that you could do in your own game to prevent player from buying tools. Like, for example, if the player is like a mile away from the shop and they're mid-fight, you don't want them just buying a bunch of ammo, saying they run out of ammo mid-fight, and they just buy a bunch of ammo even though they're not near the store, but they don't need to be because you don't have a magnitude check or a sanity check on the server to make sure that they're close enough to the store to buy ammo, that kind of thing. You don't want them just buying ammo mid-fight and just killing everybody, seeming like they have infinite ammo, something like that, right? So hopefully this is a video that helped you understand remote events a lot better, helped you understand exploits, how they work, everything like that. If you noticed in the video, I didn't really go over this, but actually I don't think the video shows it, but whenever a exploiter attaches a executor to a game or injects, there will actually be a memory spike. Pretty much the game will lag, there will be a large spike in memory, and the player will end up starting to use more memory because of just the way that the executor works internally. So that is a way some people try and measure to prevent exploiters from injecting, but it's not very accurate since other things can cause memory spikes, of course, so there could be false positives, but that is one thing to take note. Anyways, that's it. Thanks for watching. Bye.